Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at skewness. Now, you've probably come across skewness before. We describe data as positively or negatively skewed or symmetrical. Symmetrical basically means not skewed. So scores, data is positively skewed if they're clustered towards the minimum, negatively skewed if clustered towards the maximum, and symmetrical if clustered towards the center. So that part's probably not new to you. What will be new is looking at what skewed box plots would look like. So a positively skewed box plot would look like this. So why is that? Well, we're going to illustrate that by considering what the data displayed here would look like if we put it into a histogram. So remember, a histogram always has frequency on the vertical axis, score on the horizontal axis. As you move along here, scores are getting larger. Higher frequency, higher bars means the scores occurred more frequently. So let's look at what's going on in this box plot. Well, even though this is a very small distance, this still represents 25% of the scores. There's always a quarter or thereabouts, about a quarter of scores between the minimum and Q1, the lower quartile. Similarly, there's 25% of scores between Q1 and the median. So even though this distance here is a lot larger, it represents the same number, same percentage of scores. This from Q3 to maximum still represents 25%. So what's going on here? Well, because this is a very low range, what we're seeing is a lot of scores, 25% of scores within a low range. So when we draw the histogram down towards the minimum, we have a lot of scores within a low range. Now, we don't know exactly what the histogram will look like, but it'll look something like this. A lot of scores close or clustered together. So here, the distance from here to here is a little bit larger, but it still represents 25% of the scores. So we're going to have 25% of the scores now, the same number of scores, over a slightly larger range. So it'll look something like this. So this represents 50% of the scores. But then from here to here, which is a slightly larger range still, distance from here to here is a little bit more than from here to here, this still represents 25% of the scores, but because it's over a larger range, we'll still have a lot of scores, but over a larger range, the bars won't be as high. So it'll look something like this. And then here we have quite a large distance for the last 25% of scores. We have 25% of scores over a much larger range. So the bars will be lower. There will be more of the bars, they'll just be lower. This is what the histogram will look like. This is a positively skewed histogram. You can see scores are clustered towards the minimum. The minimum score is here. Now, the thing is, we don't know exactly what these scores are. Let's say these scores represented, say, performance in a maths test. So these scores down here, it doesn't mean they're 0 or 10. They could still be high. These scores could be, 80, 81, 82. When we say that data is positively skewed, we're not saying that there are a lot of low scores. We're saying that there are a lot of scores close to the minimum. So if you do a maths test, for example, the lowest score could be 80, and there could be a lot of students who scored around 80. Those students didn't score those scores. They just scored closer to the minimum. So that's what we mean with skewness. This is positively skewed, scores clustered towards the minimum. So the opposite is true if the data is negatively skewed. So here you can see there's a larger range for the bottom 25% of scores, but the top 25% of scores occur in a small range. So what we'd see here is the opposite. We'd see low bars over here, and the bars would get higher as the scores get larger. You would see scores clustered towards the maximum, and that's why a negatively skewed box plot looks like this. You have quite a high proportion, 25% of the scores in a very low range towards the maximum. So you'll have high bars closer to the maximum. And Just as you'd expect, if the box plot is symmetrical, then the corresponding histogram would be symmetrical. Here you'd have an even distribution of scores. It's basically the same range for the lowest 25 as for the top 25, as for the two middle 25% of scores. Alright, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.